Okay, we have a couple of things we need to do. And then we'll go over this if we have time. If not, we will do this on Monday when you have your papers back in your hands. What we need to do now is page 265. We need to do a few problems on this page. Because it's time that we step up into a few tougher problems than we've been looking at. So let's start by taking a look at problem number 30.
What page 260?
265. And like some in last night's homework, this one says, tell me where it equals 0, where it's positive, and where it's negative. All right? So I'm going to get my number line out. And let's start with the dots. I think it's always a good idea to start with the dots. So where are the dots going to be in this problem? You're going to have 3 of them. Where are they going to be? You're going to have a dot at 1, 4, and -2. Everybody okay with that? Now, because there's a radical in the problem, think back, months ago, what do I have to be careful of every time I see a radical in my equation? What?
It's either positive or negative.
It has to, whatever's underneath it has to be positive. So x plus 2 has to be positive, which means x has to be bigger than or equal to -2. But wait a minute, it's in the denominator, so it can't equal -2. Would you agree with me? So whatever x's I pick have to be bigger than -2. So I don't know if you caught that, I just erased this into my number line. It is not even there. You cannot pick any numbers over here because if you do, it will create an imaginary situation. Right? Okay. So let's see. Would any of those dots be able to be filled in? We already said this one can't be filled in. We can't equal -2. Can we equal 1?
Yeah.
Can we equal 1?
Yes.
Yes, yes, we can equal 1. What would be the problem? Those of you that are saying no, what would be wrong with equaling 1? Nothing. It gives you 0, right? But where does it give you 0? In the top. Is there anything wrong with that? No. So we're going to, if x equals 1, we get a value of 0. Can we color in the 4? No. So there is only one value that will make that fraction equal 0, and that value is 1. Now, where is it positive and negative? Well, I don't know. Let's start picking numbers and seeing what happens. What's the number in here?
0.
All right, let's put 0 in. 0 would make the top negative. It would make this negative and this positive. So what would be the outcome of that? Positive. So this section is positive. All right, now let's put in a number in there.
2.
2. 2 would be positive. Negative, positive.
So negative.
So this section is negative. And then 5 would be positive. Positive, positive. So that section is also positive. So to answer the question, where will I get positive answers? Well, between -2 and 1, or bigger than 4. And where will I get negative answers? Between 1 and, oh, I gotta be careful. We're gonna talk about that. Between 1 and 4?
Do you not put the greater than?
I should have put the or equal to on there
You don't-
because if I put in 1, I don't get positive, I get 0, right? So my positives are really just this section and this section, not including the 1. And my negatives are this section, not including the 1. Yeah, I gotta be careful about that. Okay? The problem looks much more complicated in some terms it is, but if you just do what you do, it should be okay. All right, let's look at another one. Number 42. Okay, not a huge deal, but it's got an absolute value in it. That's why I thought we better look at it together. So, what does this mean?
That's less than 0.
What does less than 0 mean? Negative. So you want this fraction to be negative. Where do the dots go on the number line? You're going to have 2 of them. Where are they going to be? -2 and 3. Either one of those dots is going to be colored in.
3. No.
Why not?
Oh, good.
There's no or equal to in the problem, so you would never color anything in, right, if there's no or equal to?
Yeah.
Okay, well, let's see what happens. Let's put in -3. Now remember, we want a negative outcome. So if we put in -3, we get a negative over a positive. Kids, won't that denominator always be positive?
Yeah.
So does this do for me what I wanted? Yeah, that part's gonna work. All right, let's try here. Let's put in 0. 0 gives me a negative over a positive. So that works. Let's put in 4. 4 does not work, does it? So what is our answer?
So positive. Positive when x is greater than 3.
We want to know where it's negative.
Oh.
This problem just says, where is it negative?
Oh,
So
so
we
x
would
is less
say
than
x.
-2.
If we said x is less than 3 but not equal to -2, that would work, wouldn't it? Jamie?
I thought it was
What?
the shading.
Oh, no. What's our rule about the alternating shading? Only if there is nothing out of the ordinary in the problem. We stuck an absolute value in there, that changes everything. Okay? You can't have squares, you can't have square roots, you can't have anything that's just not plain simple factors. Okay, a couple more. 52. Now this is full of weirdness, isn't it? But I'd like you just to look at it for a second. Do not be scared of it. Look at it for a second.
So it
What
needs
does
to be a
this
negative
mean?
number. It has to be a negative number.
It means we want this to come out negative. I want you to look at it for a second. What's this?
Quadratic.
That's a square. Now wait a minute. What do you know about something squared? That's positive. Unless you're in imaginary number land, which we are not, when you square something, it's positive. So will this quantity right here ever be anything other than positive?
No, think about
No.
the next one.
What about this one?
Positive.
Wait a minute. You've got an always positive times an always positive.
Not worth in this question.
Is it ever going to be negative?
No.
No. Sometimes paying attention to what's going on in the problem can really save you some time. Now, what if we turned this around and made it greater than?
All real numbers.
I knew you would say that. It isn't all real numbers. It's all real numbers except 2 and negative 5/3. Because what happens if you put in 2 or negative 5/3? You get 0. This would be all real numbers, do you see? So watch that too, be careful about that too.
Would you just put like X, you cannot equal?
Yeah.
Okay.
Yep. All right, one more. 54. Oh boy.
You know it has to be a negative number.
I know that I need to end up negative, so whatever happens, I need to end up with a negative result. We're gonna have 3 dots in this problem. Where will those 3 dots be?
4, -1, and 0.
4 and 0 and -1. Everybody getting those numbers? You got a radical, and anytime you have a radical, your domain is going to be restricted. What can you tell me about possible x's before I even start worrying about the
It
fraction?
has to be positive.
X's have to be bigger than or equal to -1. Boys and girls, one more time. Whatever is under the radical has to be bigger than or equal to 0. So x has to be bigger than or equal to -1, but wait a minute, it's in the denominator, so it can't even equal -1. It has to be bigger than -1. So there goes that part of the number line, erased. You can't have an x over here, or that will be imaginary. Okay. I don't really have a choice, I'm gonna have to pick a fraction, so I'll pick -1/2. Not a huge deal. When I square that, it's positive, right? Now when I put -1/2 in here, this would be negative. Cubed would still be negative, and that would be positive. So that section of the number line comes out negative. I know I put a fraction in, but I didn't have to do the arithmetic. This is all about SIGNs. It's all about positive and negative. Okay, so now I'm going to put in 2. 2 will give me positive. What's going to happen here if I put in 2? Negative. And positive. So that's another negative section. What if I put in 5? Positive, positive, positive. So that's a positive section. Now I wanted negative. So once again, my answer is just that much of the number line.
So it would be anything less than 4 except 0.
So I can say everything between -1 and 4 except 0. Everything in this interval except 0. And why did I take 0 out? Because when I put 0 in, this fraction would equal 0. Not be less than 0, it would equal 0. Okay? All right, so you're going to practice some of those. All right, let's see. Let's take a look at our quiz question then and see how you did. Now, I kind of gave you the questions out of order. They because you couldn't fill those in until you did the sketch first. So let's do the sketch and then we'll talk about what the answers to the questions are. Okay, so tell me what you put in your graph. Haley.
The vertical asymptote that is x equals -2.
Yep, our vertical asymptote, remember there's no P in, there's a P in the word, but you don't say it. Our vertical asymptote is at -2. You are exactly right. So far, so good? All right, what else did you put into your graph?
Slant asymptote was y equals x minus 7.
So you did the division. You said, oops, my power on top's bigger, so I'm gonna have to do my division. Disregard the remainder, but my asymptote is y equals x minus 7. So you drew in, that's supposed to be a straight line. Y equals x minus 7, perfect. All right, what else? Mahela?
There are no holes in it.
No holes. Actually, the numerator does factor, doesn't it? Which is kind of convenient. But nothing cancels, so there are no holes. Okay, Dan?
I'd say the zeros are 6, 0, and -1, 0.
Yep, -1 and 6 are your x-intercepts, or your zeros. Very good, they come straight from the numerator. You're going to set that equal to 0. So it's going to do it. Good. Grace?
The y-intercept is -3.
The y-intercept is -3.
Draw your sketch.
That is the important stuff. So you're going to get a point for all those things. Okay, so hopefully all that's in there. And then you have to connect the dots. I hope this part was kind of obvious to you. But if that's all you drew, you're in trouble
You gotta do it, Bob.
because you left half of it out. Remember, your vertical asymptote splits your picture. You have drawn the right side, but you must also draw the left side. So what did you draw?
Little thing.
Hopefully this guy down here.
Look good, yes.
Now, he looks really little, but he's really not. It's just that we got him squished up at the bottom of the page. He's as big as that. It's just squished. Everybody okay with that? So now we're going to answer the questions. Okay, tell me what the first question is over there. Can somebody tell me, please? As x approaches infinity. What's the limit as x approaches infinity? Well, where does x approach infinity? That way. So as you keep going that way, what's your pen doing? Going up. I hope you said positive infinity.
So this one.
Is the next one x approaches negative infinity?
Yeah.
So that means we're going to draw this way. So as we keep going this way, what's my pen doing? Negative infinity. What's the next one?
X approaches positive.
Positive 2 from the positive side? Wait a minute. X approaches 2.
That's an asymptote.
2 isn't an asymptote. 2's some dot, isn't it? When I ask you for a limit value, I'm asking you for a y value. What's the y value when x is 2?
-3.
I do not know, but I'm going to figure it out. What is that? -3, -12 over 4, -3. There's your answer, -3. Does this have anything to do with it? No, not when it's a point. If you're a point, it doesn't matter which side you're coming from. Your y value is the same. All right, what's the next one? -2 from the. Now that is a little different because -2 is not a point. -2 is an asymptote. So this matters a lot. I'm coming from the right side. As I approach my asymptote, I cannot touch it, so I must turn. Which way am I turning? Up. And what's the last one?
0, -0.
And again, I don't even care, I'm sure I put something there, but I don't even care what it is, because 0 is a point. So that's gonna be -3. Okay, Bailey? Oh, Pam's not after your high five. All right, here's the question you have to ask yourself. How much of that did you do and how much did your partner do? Because on Monday, you're gonna do it all by yourself. Got it? Okay, go ahead and start your homework. On Monday, we're going to start reviewing for a test on Thursday.